We concluded our session last time with the discussion of Leibniz's argument from contingency for the existence of God. And after class yesterday, I reflected a bit more on a couple of questions that were posed in the discussion time here concerning what effect would it have on the argument if we were to think of the universe not as a huge material object, but rather as a set of material objects, whether these be planets, stars, galaxies, and so forth, or these be fundamental particles like quarks and electrons. And it occurred to me that if we do adopt the view that the universe is a set of things, then it becomes all the more obvious that the universe does not exist by a necessity of its own nature. And the reason for that is that the peculiar property of sets is that they have their members essentially. If two sets differ in even one member, then they are not the same sets. Sets are constituted by their membership. And so sets that have different members are essentially different. They are not the same set. So what that means is that if one single quark more were to exist in addition to those that exist, or a single fewer quarks were to exist than those that exist, or one quark were substituted for a quark that exists, you would have a different universe because you would have a different set. And so that makes it, I think, all the more obvious that if the universe has an explanation, then that explanation is to be found in a transcendent cause rather than a necessity of its own nature. If the universe is a set, it has to have all of its members essentially, and that would require you to say that every single quark, every particle in the universe is a metaphysically necessary being, which just seems outrageous. Well, today we turn to a new question and a new argument. Where did the universe come from? Sometimes called the Kalam Cosmological Argument. Al-Ghazali was a 12th century Muslim theologian from Persia, or modern-day Iran. He was concerned that Muslim philosophers of his day were being influenced by Greek philosophy to deny God's creation of the universe. They held that the universe flows necessarily out of God and therefore is beginningless in its being. After thoroughly studying the writings of these philosophers, Al-Ghazali wrote a withering critique of their views entitled The Incoherence of the Philosophers. In this fascinating book, he argues that the idea of a beginningless universe is absurd. The universe must have a beginning, and since nothing can come into being without a cause, there must be a transcendent creator of the universe. Now, Al-Ghazali formulates his argument very simply. It's on the PowerPoint slide. Every being which begins to exist has a cause for its beginning. Now the world is a being which begins, therefore it possesses a cause for its beginning. Or, in other words, premise one, whatever begins to exist has a cause. 2, the universe began to exist. 3, therefore, the universe has a cause. Now, this little argument is so marvelously simple that it's easy to memorize and share with another person. It's also a logically airtight argument. If the two premises are true, then the conclusion necessarily follows. So, anybody who wants to deny the conclusion has to regard either premise 1 or premise 2 as false. So, the whole question comes down to this. Is it more probable that these premises are true or that they are false? That will be the question before us this afternoon. In order to make this argument easier to understand, We will now look at a video that we've developed at Reasonable Faith illustrating this argument.
Does God exist? Or is the material universe all that is, or ever was, or ever will be? One approach to answering this question is the cosmological argument. It goes like this: whatever begins to exist has a cause. The universe began to exist, therefore, the universe has a cause. Is the first premise true? Let's consider. Believing that something can pop into existence without a cause is more of a stretch than believing in magic. At least with magic, you've got a hat and a magician. And if something can come into being from nothing, then why don't we see this happening all the time? No, everyday experience and scientific evidence confirm our first premise. If something begins to exist, it must have a cause. But what about our second premise? Did the universe begin, or has it always existed? Atheists have typically said that the universe has been here forever. The universe is just there, and that's all. First, let's consider the second law of thermodynamics. It tells us the universe is slowly running out of usable energy, and that's the point. If the universe had been here forever, it would have run out of usable energy by now. The second law points us to a universe that has a definite beginning. This is further confirmed by a series of remarkable scientific discoveries. In 1915, Albert Einstein presented his general theory of relativity. This allowed us, for the first time, to talk meaningfully about the past history of the universe. Next, Alexander Friedmann and George Lemaitre, each working with Einstein's equations, predicted that the universe is expanding. Then in 1929, Edwin Hubble measured the red shift in light from distant galaxies. This empirical evidence confirmed not only that the universe is expanding, but that it sprang into being from a single point in the finite past. It was a monumental discovery, almost beyond comprehension. However, not everyone is fond of a finite universe, so it wasn't long before alternative models popped into existence. But one by one, these models failed to stand the test of time. More recently, three leading cosmologists, Arvind Borde, Alan Guth, and Alexander Vilenkin, proved that any universe which has on average been expanding throughout its history cannot be eternal in the past, but must have an absolute beginning. This even applies to the multiverse, if there is such a thing. This means that scientists can no longer hide behind a past eternal universe. There is no escape. They have to face the problem of a cosmic beginning. Any adequate model must have a beginning, just like the standard model. It's quite plausible then that both premises of the argument are true. This means that the conclusion is also true. The universe has a cause. And since the universe can't cause itself, its cause must be beyond the space-time universe. It must be spaceless, timeless, immaterial, uncaused, and unimaginably powerful, much like God. The cosmological argument shows that, in fact, it is quite reasonable to believe that God does exist.
Let's examine each premise of the cosmological argument in detail. I think that the first premise, that whatever begins to exist has a cause, is virtually undeniable for any sincere seeker after truth. For something to come into being without a cause, any cause whatsoever, would be to come into being from nothing, and that is surely impossible. So let me give three reasons in support of this premise. Number one, something cannot come from nothing. To claim that something can come from nothing is worse than magic. When a magician pulls a rabbit out of a hat, at least you've got the magician, not to mention the hat. But if you deny premise one, you've got to think that the whole universe just appeared at some point in the past for no reason whatsoever. But nobody sincerely believes that things, say a horse or an Eskimo village, can just pop into being without a cause. Sometimes skeptics will respond to this point by saying that in physics, subatomic particles, so-called virtual particles, come into being from nothing. Sometimes skeptics will respond by saying that in physics, subatomic particles, so-called virtual particles, can come into being from nothing. Or on certain theories of the origin of the universe, they are described in popular magazines as getting something from nothing, so that the universe is the exception to the proverb, there ain't no free lunch. This skeptical response, I think, however, represents a deliberate abuse of science. The theories in question have to do with particles, or the universes, coming into being as a fluctuation of the energy which is contained in the vacuum. And the vacuum in modern physics is not what the layman understands by the word vacuum, namely nothing. Rather, in physics, the vacuum is a sea of fluctuating energy governed by physical laws and having a physical structure. To tell lay people that on such theories something comes into being from nothing is a distortion of those theories. And there is, by the way, here a very good lesson to learn. You have to be very, very leery of popular articles and television shows on scientific theories. In order to communicate these highly technical theories to lay audiences, writers inevitably resort to metaphors and word pictures that can be grossly misleading and inaccurate. And the claim that physics shows that something can come from nothing is a case in point. Properly understood, nothing does not mean just empty space. Nothing is a term of universal negation, meaning not anything. It does not refer to any positive reality. Nothing is the absence of anything whatsoever, even space itself. As such, nothingness literally has no properties at all, since there isn't anything there to have any properties. How silly then when popularizers say things like, nothingness is unstable to quantum fluctuations, or the universe tunneled into being out of nothing. When I first published my work on the Kalam Cosmological Argument back in 1979, I figured that atheists would attack premise 2 of the argument, that the universe began to exist. But I didn't think that they would go after premise 1, for that would expose them as people who are only interested in an academic refutation of the argument, rather than as sincere seekers after truth. What a surprise, then, to hear atheists challenging and denying premise 1 in order to escape the argument. For example, Quentin Smith of the University of Western Michigan has responded that the most rational position to hold is that the universe came from nothing, by nothing, and for nothing. A sort of good close to a Gettysburg Address of atheism, perhaps. Now, this is simply the faith of an atheist. In fact, I think it represents a greater leap of faith than belief in the existence of God. For it is, as I say, literally worse than magic. If this is the alternative to belief in God, then unbelievers can never accuse believers of irrationality, for nothing could be more evidently irrational than this. The second reason is that if something can come into being from nothing, then it becomes inexplicable why just anything and everything doesn't come into being from nothing. Think about it. Why don't bicycles and Beethoven and root beer just pop into being from nothing? Why is it only universes that can come into being from nothing? What makes nothingness so discriminatory? There can't be anything about nothingness that favors universes, because nothingness doesn't have any properties, nor can anything constrain nothingness to universes, for there isn't anything there to be constrained. I've heard atheists respond to this argument by saying that premise one is true of everything in the universe, but it is not true of the universe. But this is just the old taxicab fallacy again that we confronted with respect to Leibniz's argument. You can't dismiss the causal principle like a taxicab once you get to the universe. Premise one is not merely a law of nature, like the law of gravity, which only applies in the universe. Rather, it is a metaphysical principle that governs all being, all reality. Now, at this point, the atheist is likely to retort, all right, if everything has a cause, then what is God's cause? I'm always amazed at the self-congratulatory attitude with which students pose this question. They've imagined that they've said something profound or important when all they've done is misunderstand the premise. Premise one does not say that everything has a cause. Rather, it says that everything that begins to exist has a cause. Something that is eternal wouldn't need a cause because it never came into being. Al-Ghazali would therefore respond that God is eternal and uncaused. And notice this is not special pleading for God, since this is exactly what the atheist has traditionally said about the universe. The universe is eternal and uncaused. The problem is that we now have good evidence that the universe is not eternal, but had a beginning. And so the atheist is backed into the corner of saying the universe sprang into being without a cause, which seems to be absurd. Finally, number three, common experience and scientific evidence confirm the truth of premise one. Premise one is constantly verified and never falsified. It's hard to understand how any atheist who believes in modern science could deny that premise one is more plausibly true than false in light of the evidence. So I think that the first premise of the Kalam cosmological argument is clearly true if the price of denying the argument's conclusion is denying premise one, then atheism seems to me to be philosophically bankrupt. Now, is there any question of that defense of premise one?
I know that this is probably an evident question. I just don't understand it. I've had atheists ask me, so if you think, so who caused God? Where did God come from? And I don't quite understand the difference in how that's...
All right. The first premise of this argument says everything that begins to exist has a cause. It does not say everything that exists has a cause. And therefore, something that doesn't begin to exist wouldn't be required to have a cause, according to this premise. If something never began to exist, it would simply be eternal and uncaused. What has happened is that people have confused premise one of Leibniz's argument with premise one of the Kalam cosmological argument. They've conflated them together. Leibniz's argument says everything that exists has an explanation of its existence, either in the necessity of its own nature or in an external cause. This argument says everything that begins to exist has a cause. And people conflate the two and come up with the premise everything that exists has a cause, which no one has ever maintained. So it's just based on a confusion. God is a metaphysically necessary being, as we saw yesterday, who exists by a necessity of his own nature. He never began to exist, and so he doesn't need a cause. Is that clear? Okay. So don't confuse premise one of this argument with premise one of Leibniz's argument.
Yes, Dr. Craig, why can't the universe go be eternal as well?
That's the second premise. We haven't gotten to that yet. All right, so in defense of the first premise, then again, to recap, something cannot come into being out of nothing. Secondly, if things could come into being out of nothing, then it's inexplicable why just anything and everything doesn't come into being out of nothing. And thirdly, common experience and scientific evidence support the truth of premise one. The more controversial premise in the argument is therefore premise two, that the universe began to exist. Now, the video presented only scientific evidence in support of this premise, evidence which wasn't available during Al-Ghazali's time. Al-Ghazali presented philosophical arguments in support of this premise. So let me present two philosophical arguments and two scientific confirmations of the beginning of the universe. Al-Ghazali argued that if the universe never began to exist, then there have been an infinite number of past events prior to today. But, he argued, an infinite number of things cannot exist. Now, Al-Ghazali recognized that a potentially infinite number of things could exist, but he denied that an actually infinite number of things could exist. Let me explain the difference. When we say that something is potentially infinite, infinity serves merely as an ideal limit, which is never reached. For example, you could divide any finite distance in half, and then into quarters, and then into eighths, and then into sixteenths, and so on to infinity. The number of divisions is potentially infinite, in the sense that you could go on dividing endlessly. But you would never arrive at an infinitieth division. You would never have an actually infinite number of parts or divisions. Now, Al-Ghazali has no problem with the existence of merely potential infinites because these are just ideal limits. But he argued that if an actually infinite number of things could exist, then various absurdities would result. If we are to avoid these absurdities, then we must deny that an actually infinite number of things could exist. That means that the number of past events cannot be actually infinite. Therefore, the universe cannot be beginningless, rather the universe began to exist. It's very frequently alleged that this kind of argument has been invalidated by developments in modern mathematics. In modern set theory, the use of actually infinite sets is commonplace. For example, the set of natural numbers, 0, 1, 2, 3, and so on, has an actually infinite number of members in it. The number of members in this set is not merely potentially infinite, according to modern set theory. Rather, the number of members is actually infinite. And many people have mistakenly assumed that these developments undermine Al-Ghazali's argument. These developments in modern mathematics, however, merely show that if you adopt certain axioms and conventions, then you can talk about actually infinite collections in a consistent way without contradicting yourself. All this accomplishes is showing how to set up a certain universe of discourse for talking consistently about actual infinites. But it does absolutely nothing to show that such mathematical entities really exist or that an actually infinite number of things could exist. If Al-Ghazali is right, then this universe of discourse may be regarded as just a fictional realm, like the world of Sherlock Holmes, or something that exists only in your mind. Moreover, Al-Ghazali's claim is not that the existence of an actually infinite number of things involves a logical contradiction, but rather that it is really impossible. To give an analogy, the claim that something came into existence from nothing is not logically impossible. It doesn't involve a self-contradiction, but nonetheless, it is really impossible. These modern mathematical developments, far from undermining Ghazali's argument, actually strengthen it by providing us insight into the strange nature of the actual infinite. The way in which Ghazali brings out the real impossibility of an actually infinite number of things is by imagining what it would be like if an actually infinite collection of things could exist, and then drawing out the absurd consequences. Let me share one of my favorite illustrations called Hilbert's Hotel, the brainchild of the great German mathematician David Hilbert. Hilbert first invites us to imagine an ordinary hotel with a finite number of rooms. Suppose, furthermore, that all the rooms are full. If a new guest shows up at the desk asking for a room, the manager says, "Sorry, all the rooms are full." And that's the end of the story. But now, says Hilbert, let's imagine a hotel with an infinite number of rooms, and let's suppose, once again, that all the rooms are full. Now, this fact needs to be clearly appreciated. There is not a single vacancy throughout the entire infinite hotel. Every room already has a flesh and blood person in it. Now, suppose a new guest shows up at the front desk asking for a room. "No problem," says the manager, and he moves the person who was staying in room 1 into room 2, the person who was staying in room 2 into room 3, the person who was staying in room 3 into room 4, and so on out to infinity. As a result of these room changes, room number 1 now becomes vacant, and the new guest gratefully checks in. But remember, before he arrived, all the rooms were full. It gets even worse. Let's now suppose, Hilbert says, that an infinity of new guests shows up at the front desk asking for rooms. "No problem," says the manager. And he moves the person who was staying in room 1 into room 2. He moves the person who was in room 2 into room 4. He moves the person who was in room 3 into room 6, putting every person into the room with a number twice his former room number. Now, since any number multiplied by 2 is always an even number, all of the guests wind up in the even-numbered rooms. As a result, all of the odd-numbered rooms now become vacant and the infinity of new guests is easily accommodated. In fact, the manager could do this an infinite number of times and always accommodate infinitely more guests. And yet, again, before they arrived, all the rooms were already full. As a student once remarked to me, if Hilbert's hotel could exist, it would have to have a sign posted outside, "No vacancy, guests welcome." But Hilbert's hotel is even stranger than the great German mathematician made it out to be. For just ask yourself the question, what would happen if some of the guests start to check out? Suppose all the guests in the odd-numbered rooms check out. In this case, an infinite number of people has left the hotel. Indeed, as many people have left as remained behind. And yet, there would be no fewer people in the hotel. The number would just be infinite. Now, suppose the manager doesn't like having a half-empty hotel. It looks bad for business. No problem. By moving the guests as before, only in reverse order, he can convert his half-empty hotel into one that is bursting at the seams. Now, you might think that by these maneuvers, the manager could always keep this strange hotel fully occupied. But you'd be wrong. For suppose the guests in rooms 4, 5, 6, and so on out to infinity check out. At a single stroke, the hotel would be virtually empty, the guest register reduced to but 3 names, and the infinite converted to finitude. And yet, it would be the case that the same number of guests checked out this time as when all of the guests in the odd-numbered rooms checked out. Can anyone believe that such a hotel could exist in reality? Hilbert's hotel is absurd. Since nothing hangs on the illustrations involving a hotel, the argument can be generalized to show that the existence of an actually infinite number of things is absurd. Now, sometimes people respond to Hilbert's hotel by saying that these absurdities result because the concept of infinity is beyond us and we can't understand it. But this reaction is mistaken and naive. As I said, infinite set theory is a highly developed and well understood branch of modern mathematics. The absurdities result because we do understand the nature of the actual infinite. Hilbert was a smart guy, and he well knew how to illustrate the bizarre consequences of the existence of an actually infinite number of things. Really, the only thing that the critic can do at this point is just bite the bullet and say that Hilbert's hotel is not absurd. Sometimes critics will try to justify this move by saying that if an actual infinite could exist, then such situations are exactly what we should expect. But this justification is inadequate. Hilbert would of course agree that if an actual infinite could exist, then the situation with his imaginary hotel is what we would expect. Otherwise, it wouldn't be a good illustration, would it? But the question is whether such a hotel is really possible. Moreover, the critics can't just bite the bullet when it comes to situations like the guests checking out of the hotel. For here, we do have a logical contradiction. We subtract identical quantities from identical quantities and come up with non-identical results. And that's why subtraction of infinity from infinity is mathematically prohibited. But while we may slap the hand of the mathematician who tries to break the rules, we can't stop real people from checking out of a real hotel. So I think that Ghazali's first argument is a good one, and it shows that the number of past events must be finite. Therefore, the universe must have had a beginning. Any question about this first philosophical argument for the beginning of the universe?
I think this was a terrific articulation of the Hilbert Hotel. And are you going to get into continuity of time? Because
No, I'm not. Did you want to pose a question about that?
Yeah, so
All right.
what I see here is a contradiction against Zeno's paradox, where
Say again now.
I see a contradiction against Zeno's paradox. You know, I walk halfway to you, and then I'm
Yes.
going to walk half the additional distance and
Yeah.
half the additional distance, so I end up never getting to you. But that's not really the way things work, because space is continuous, time is continuous, and so the difference here being that Hilbert's Hotel deals with discrete quantities.
Yes.
If you're working with a hotel that has a continuous number of rooms rather than a discrete number, you couldn't even get to room number one. So I guess my question is that are we talking about a discrete count, like a countable size of infinity versus an uncountable size of infinity? Like,
We are talking about a denumerable infinity. I haven't even broached the subject of non-denumerable infinites. And in set theory, the members of a set must be definite and discrete elements. So we are talking about discrete objects, like rooms. We're not talking about points, like on a continuum, which have no extension. In my book, The Kalam Cosmological Argument, you'll find a very interesting appendix on Zeno's paradoxes and the Kalam Cosmological Argument. And I think that the solution to Zeno's paradoxes is Aristotle's solution, namely that it concerns potential infinity only, not actual infinites. The distance between 2 points is not composed of an actually infinite number of points. Rather, it is logically prior to any points that I want to denominate in it. And so I can continue to divide up the distance ad infinitum, but that forms only a potential infinite, not an actual infinite. And so if we think of Zeno's paradoxes in terms of potential infinites, they pose no counterexample to Hilbert's claim that an actual infinite cannot exist. Yes?
Right. When you talk about real infinity, no matter it's countable or uncountable, it always results in some very partial things.
They're always what?
Always result in very strange things.
Yes.
Yeah, that's as you point out.
Yes.
I say that it's a good illustration for Trinity. Because we say that we say 3 persons are one God. Even you take out, but you just consider, God the Father, or just consider God the Son. Each one is fully God. It's 100% God.
Yes, I disagree with that. I think that that's incorrect. I think you're going to land in a logical contradiction there if you say that. And I don't think that the doctrine of the Trinity is logically contradictory or logically incoherent. If you're interested in my take on the Trinity, look at the book I did with J.P. Moreland called Philosophical Foundations for a Christian Worldview. And there's a chapter on the Trinity where I lay out a model for God's being tri-personal. He is a tri-personal spiritual substance. And I don't think there's any logical incoherence in that. And that's a good thing, because I think as Christians we would be in deep, deep trouble if at the center of our theology lay a logical incoherence.
So we just proved that actually infinite things can't exist. So why does that not apply to God? How can
Okay,
that be?
excellent question. The argument here concerns what is called a quantitative infinite, not a qualitative infinite. It concerns collections that have an actually infinite number of definite and discrete finite members or elements in it. It's not talking about something that's qualitatively infinite. And when theologians talk about God as infinite, they are clearly not talking about a quantitative mathematical concept. They're not saying that God is composed of an actually infinite number of finite pieces or bits. Rather, they mean things like that God is omnipotent, that he's omnipresent, that he's morally perfect, that he's eternal, that he's omnipresent, and so forth. And none of these are quantitative concepts. So I think that infinity applied to God is a qualitative concept to express these omni-attributes of God. And it is not a mathematical or quantitative concept of a collection of an actually infinite number of definite and discrete finite particulars.
He said that space and time were continuous, whereas modern science is saying that
You mean this gentleman did?
Yes.
Yes, okay.
I was saying...
Okay.
Current science has space and time both as discrete, with Planck time and space, and kind of going along with quantum theory.
Yes. This is correct. It's an open question as to whether space and time are continuous. In general relativity theory, they're conceived to be continuous. But as he says, in quantum theory, they're not. Space and time are discrete. They're composed of little indivisible units. Well, and this is the problem. See, this is the incredible thing, is that modern physics rests upon the twin pillars of general relativity and quantum theory, and these two theories are incompatible with each other. And nobody knows how to reconcile them. They have different views of time and space. So if one is uncomfortable with the continuity of time and space, then it is quite open to a person to adopt a quantum theoretical view and say, no, time and space are made up of discrete units. Time is made up of little intervals called chronons, which are little indivisible moments of time, and is not therefore infinitely divisible and composed of points. So this is an open question. And so that cannot be used as a counterexample to refute Al-Ghazali's claim that an actually infinite number of things cannot exist. Al-Ghazali has a second independent argument for the beginning of the universe. So those who deny that the universe began to exist have to refute not only his first argument, but also the second one as well, because it is independent of the first one. The series of past events, Al-Ghazali observes, has been formed by adding one member after another. The series of past events is like a sequence of dominoes falling one after another until the last domino today is reached. But, he argues, no series which is formed by adding one member after another can be actually infinite, for you cannot pass through an infinite number of elements one at a time. Now, this is easy to see in the case of trying to count to infinity. No matter how high you count, there is always an infinity of numbers left to count. But if you can't count to infinity, how could you count down from infinity? This would be like someone's claiming to have counted down all the negative numbers, ending at 0, -3, -2, -1, 0. This seems crazy. For before he could count -1, he would have to count -2. But before he could count -2, he would have to count -3. But before he could count -3, he would have to have counted -4, and so on, back to infinity. Before any number could be counted, an infinity of prior numbers will have to have already been counted first. You just get driven back and back into the past so that no number could ever be counted. But then the final domino could never fall if an infinite number of dominoes had to fall first. So today could never arrive. But obviously, here we are. That shows that the series of past events must be finite and therefore have a beginning. Now, some critics have responded to this argument by pointing out that even in a beginningless past, every event in the past is only a finite distance from the present. Compare the series of negative numbers, -3, -2, -1, 0. It's beginningless. Nevertheless, any number in the series you pick, say -11 or -1 million or whatever, is only finitely distant from 0. But the finite distance from any past event to the present is easily crossed, just as you can count down to 0 from any negative number you pick. This objection commits a logical fallacy called the fallacy of composition. This is the fallacy of confusing a property of a part with a property of the whole. For example, every part of an elephant may be light in weight, but that doesn't imply that the whole elephant is light in weight. In the case at hand, just because every finite part of a series can be crossed or counted down doesn't mean that the whole infinite series can be crossed or counted. The critics have committed an elementary logical fallacy. The question is not how any finite part of the past can be formed by adding one member after another, but rather how the whole beginningless past could be completed by adding one event after another. Al-Ghazali sought to heighten the impossibility of forming an infinite past by giving illustrations of the absurdities that would result if it could be done. For example, suppose that for every one orbit that Saturn completes around the sun, Jupiter completes 2 orbits. The longer they orbit, the farther Saturn falls behind. If they were to continue to orbit forever, they would approach a limit at which Saturn is infinitely far behind Jupiter. Of course, they will never actually arrive at such a limit. But now, turn the story around. Suppose that Jupiter and Saturn have been orbiting the sun from eternity past, which will have completed the most number of orbits. The answer is that the number of their orbits is exactly the same, namely infinity. And don't let the skeptic try to get out of this argument by saying that infinity is not a number. In modern mathematics, it is a number. It is the number of elements in the set 0, 1, 2, 3, and so on to infinity. But that seems absurd because the longer they orbit, the greater the disparity between them grows. So how does the number of orbits magically become equal by making them orbit from eternity past? Another illustration. Suppose we meet someone who claims to have been counting down from eternity past and is now finishing. -3, -2, -1, 0. Whew. Why, we may ask, is he just finishing his countdown today? Why didn't he finish yesterday? Or the day before that? After all, by then an infinite amount of time had already elapsed. So if the man were counting at the rate of, say, 1 number per second, he's already had an infinite number of seconds to finish his countdown. He should already be done. In fact, at any point in the past, the man will have already had an infinite amount of time and so should already have finished. But then at no point in the past could we find the man finishing his countdown, which contradicts the hypothesis that he has been counting from eternity past. These illustrations only strengthen Al-Ghazali's claim that no series which is formed by adding one member after another can be actually infinite. Since the series of past events has been formed by adding one member after another, it can't be actually infinite. It must have had a beginning. And so we have a second philosophical argument for premise 2 of the Kalam cosmological argument, that the universe began to exist. Any question or discussion of Ghazali's second argument for the finitude of the past? This is actually the argument that's more closely related to Zeno's paradoxes, because it involves the notion of trying to get through an infinite series by going through one member at a time. And if you think of the elements as discrete and actual, then I think Zeno's right. You could never do it. You couldn't get through an actually infinite collection by successive addition. Yes, okay?
I just had a comment on, with these type of elementary logical fallacies being made by people who want you to accept their conclusions, they're so ludicrous. It reminds me of Lewis Carroll and, Alice and all of his gently mocking of nominal logicians with Humpty Dumpty, giving meaning to words and things that he just makes up out of thin air. So I guess my question is, forget about God, forget about eternity. Why would you trust them about anything except, with physical things even, with the age of the world, with
yes.
the
Well,
size of the
at
universe?
this point, we haven't brought God into the picture in any way. Hilbert, as far as I know, was not a theist. I don't know if he was a theist or not. But what we're talking about here is a purely secular issue with respect to the possibility of the infinitude of the past. Is it possible for the past to be infinite and beginningless? And I think that these arguments provide pretty persuasive, entirely non-religious arguments for thinking that such a thing is impossible and that therefore the past must be finite. In one of the most astonishing developments of modern astronomy, which Ghazali could never have anticipated, is that we now have scientific evidence for the beginning of the universe. Yes, science provides some of the most dramatic evidence for the second premise of the Kalam cosmological argument. The first scientific confirmation of the universe's beginning comes from the expansion of the universe. All throughout history, men have assumed that the universe as a whole was unchanging. Of course, things in the universe were moving about and changing, but the universe itself was just there, so to speak. This was also Albert Einstein's assumption when he began to apply his new theory of gravity, called the general theory of relativity, to the universe in 1917. But Einstein found that there was something terribly amiss. His equations described a universe which was either blowing up like a balloon or collapsing in upon itself. Perplexed, Einstein solved the problem by fudging his equations, adding a new term to enable the universe to walk the tightrope between exploding and imploding. During the 1920s, the Russian mathematician Alexander Friedmann and the Belgian astronomer Georges Lemaitre decided to take Einstein's equations at face value, and as a result, they independently came up with models of an expanding universe. In 1929, the American astronomer Edwin Hubble, through tireless observations at Mount Wilson Observatory, made a startling discovery that verified Friedmann and Lemaitre's theory. He found that the light from distant galaxies appeared to be redder than it should. This red shift in the light from distant galaxies was most plausibly due to the stretching of the light waves as the galaxies are moving away from us. Wherever Hubble trained his telescope in the night sky, he observed this same red shift in the light from the galaxies. It appeared that we are at the center of a cosmic explosion, and all of the other galaxies are flying away from us at a fantastic speed. Now, according to the Friedmann-Lemaitre model, we are not really at the center of the universe. Rather, any observer on any galaxy will look out and see the other galaxies moving away from him. There is no center of the universe. This is because, according to the theory, it is really space itself which is expanding. The galaxies are actually at rest in space, but they recede from one another because space itself is expanding. Now, to get a picture of this, imagine a balloon with buttons glued on the surface. The buttons are stuck in place and so do not move across the surface of the balloon. Nevertheless, as you inflate the balloon, the buttons get further and further apart because the surface of the balloon is stretching. And so they will appear to recede from each other in accordance with the inflation of the balloon. Now notice that there is no center to the balloon's surface. An observer on any button will look out and feel as though he were at the center of the expansion, because he'll look out and see that all of the other buttons are moving away from him. Now, the two-dimensional surface of the balloon is analogous to our three-dimensional space, and the buttons represent the galaxies in space. The galaxies are actually at rest in space, but they recede from one another as space itself expands. And just as there is no center to the balloon's surface, so there is no center of the universe. The Friedmann-Lemaitre model eventually came to be known as the Big Bang Theory. But that name can be misleading. Thinking of the expansion of the universe as a sort of explosion could mislead us into thinking that the galaxies are moving out into a pre-existing empty space from a central point. And that would be a complete misunderstanding of the model. The Big Bang did not occur at some point in a pre-existing empty space. So, we mustn't be misled into thinking of the Big Bang as the explosion of a super dense pellet of matter into empty space. The theory is much more radical than that. Now, as you trace the expansion of the universe back in time, everything gets closer and closer together. If our balloon had no minimum size, then as it shrinks going back in time, eventually any 2 points on its surface would come to coincide. The distance between them would be shrunk to 0. According to the Friedmann-Lemaitre model, that's what happens to space as you go back in time. Eventually, the distance between any 2 points in space becomes 0. You can't get any closer than that. So at that point, you have reached the boundary of space and time. Space and time cannot be extended any further back than that. It is literally the beginning of space and time. Now, to get a picture of this, imagine our universe as a two-dimensional disk, which shrinks as you go back in time, so that the geometry of space and time has the geometry of a cone. Now, notice that although a cone can be extended in one direction, in the other direction, it cannot be extended, but reaches a boundary point beyond which it cannot be extended. Since this dimension represents time, and the point of the cone lies in the past, that implies that the universe is finite in the past and had a beginning. Because space-time is the arena in which all matter and energy exist, the beginning of space-time is also the beginning of all matter and energy. It is the beginning of the universe. Now, notice that there is simply nothing prior to the boundary of space-time. But let's not be misled by words. When I say there is nothing prior to the initial boundary, I do not mean that there is some state of affairs prior to it, and that is a state of nothingness. That would be to treat nothing as though it were something. Rather, I mean that at that boundary point, it is false that there is something prior to this point. It is false that there is something prior to this point. The standard Big Bang model thus predicts an absolute beginning to the universe. If this model is correct, then we would have amazing scientific confirmation of the second premise of the Kalam cosmological argument. So, is the model correct? Or more importantly, is it correct in predicting a beginning of the universe? Well, we've already seen that the redshift and the light from distant galaxies provides powerful evidence for the Big Bang. In addition, the best explanation for the abundance of certain light elements like helium in the universe is that they were formed in the hot, dense Big Bang. Finally, the discovery in 1965 of a cosmic background of microwave radiation is best explained as a vestige of the Big Bang. Nevertheless, the standard Big Bang model will need to be modified in various ways. The model is based, as we've seen, on Einstein's general theory of relativity. But Einstein's theory breaks down when space is shrunk down to subatomic proportions. We'll need to introduce quantum physics at that point, and nobody knows how this is to be done. Moreover, the expansion of the universe is probably not constant, as in the standard model. It's probably accelerating, and it may have had a brief moment of super rapid expansion in the past. But none of these adjustments need affect the fundamental prediction of the absolute beginning of the universe. Indeed, physicists have proposed scores of alternative models over the decades since Friedmann and Lemaitre's work, and those that do not have an absolute beginning have been repeatedly shown to be unworkable. To put it more positively, the only viable non-standard models are those that involve an absolute beginning of the universe. Now, that beginning may or may not involve a beginning point, but on theories such as Stephen Hawking's famous no-boundary proposal that do not have a point-like beginning, the past is still finite, not infinite. The universe has not existed forever according to such theories, but came into existence even if it didn't do so at a sharply defined point. In a sense, the history of 20th century cosmology can be seen as a series of one failed attempt after another to avoid the absolute beginning predicted by the standard Big Bang model. Unfortunately, the impression arises in the minds of laymen that the field of cosmology is in constant turnover with no lasting results. What the layman doesn't understand is that this parade of failed theories only serves to confirm the prediction of the standard model that the universe began to exist. That prediction has now stood for nearly 100 years throughout a period of enormous advances in observational astronomy and creative theoretical work in astrophysics. Indeed, something of a watershed appears to have been reached in 2003 when three leading cosmologists, Arvind Borde, Alan Guth, and Alexander Vilenkin, were able to prove that any universe, which is on average in a state of cosmic expansion throughout its history, cannot be infinite in the past, but must have a past space-time boundary. Their theorem implies that even if our universe is just a tiny part of a so-called multiverse composed of many universes, the multiverse must have an absolute beginning. Vilenkin is blunt about the implications, and I quote, "It is said that an argument is what convinces reasonable men, and a proof is what it takes to convince even an unreasonable man. With the proof now in place, cosmologists can no longer hide behind the possibility of a past eternal universe. There is no escape. They have to face the problem of a cosmic beginning," end quote. Now, we can fully expect that new theories will be proposed attempting to avoid the universe's beginning. Such proposals are to be welcomed, and we have no reason to think that they will be any more successful than their failed predecessors. Now, of course, scientific results are always provisional. Nevertheless, it's pretty clear which way the evidence points. Today, the proponent of the Kalam cosmological argument stands comfortably within the scientific mainstream in holding that the universe began to exist. Any question or discussion of that first scientific confirmation of the premise that the universe began to exist? Yes?
Apparently, there's some evidence that parts of the universe are accelerating more rapidly than other parts of the universe that seem to be slowing down. Does that have any relevance to what you've just been telling us about?
Well, it has relevance to this question of the acceleration of the universe that I spoke of. But the Borde-Guth-Vilenkin theorem would show that even if the acceleration of the universe takes place at different rates in different parts of the universe, that as you go back in time, it can't go to infinity. It will reach a space-time boundary. So while this is very significant for understanding what is driving the acceleration of the universe, it should not affect the prediction of an absolute beginning.
So I guess my question would be discussing the expansion of the universe. if it is actually accelerating, it gets to a point where it's actually gets beyond a point of the speed of light.
It's beyond the point what?
Of the speed of light, which means that that would escape our ability to discover those parts of the universe in the future. And do you think that maybe God has actually placed us here at a specific moment in time to discover his universe?
Oh, this is a very, very interesting question, which has to do with the next argument we'll look at, the fine-tuning of the universe. Up till now, the burden of the fine-tuning argument has been that the universe is exquisitely fine-tuned for our existence. But the newest wrinkle in the fine-tuning argument is the one that you mentioned, is that in fact the universe is fine-tuned for us to discover rationally the structure and the properties of the universe and our place in it, and that it has to be very specially fine-tuned in order to make scientific inquiry possible. And so some theorists are arguing, in fact, that this betokens intelligent design and is a kind of ratification of the Creator's desire for us to do science and to explore his universe and understand its laws and how it operates. Yes?
The Big Bang theory is very standard in the science now. Because two groups of scientists, they received Nobel Prize just because of their contribution to the Big Bang theory. So,
okay, now I didn't understand. Could you articulate a little more clearly what you were saying?
Oh, I just say that what you say is acceptable in scientific.
Is unacceptable?
No, it's acceptable.
It is
acceptable in scientific community.
Yes.
Because already two groups of scientists, they received Nobel Prize in physics because of their contribution to the Big Bang theory. So that is a standard theory, almost standard theory right now.
I didn't quite understand everything that you said with the acoustics and your accent, but one of the great things about this argument is, I think you were saying, is that the defender of the Kalam cosmological argument isn't bucking up against science. On the contrary, he stands right in the mainstream of current scientific thought about astrophysics and cosmology. And that's a very comfortable place to be in arguing for theism. Any other comment on this? Yes, this gal here.
These are not, they don't seem to be at all arguments in the philosophical realm. They're obviously in more scientific arena. So my question is, being that it isn't in more of a scientific field, how do the new atheists respond to you? I mean, proponents of the new atheist movement, how do they respond when you, these seem like very airtight arguments?
Yes. Well, Dawkins doesn't respond to this argument at all, except to say that it doesn't prove the existence of a God who answers prayer, knows the future, is providentially directing everything, which is kind of a lame objection because the argument is intended to prove those sorts of things. So he doesn't really dispute the argument. He just thinks that it doesn't give you a full theological concept of God, but it certainly gives you enough to make the atheist feel uncomfortable, I think. Lawrence Krauss is a prominent physicist who will respond that the universe can come into being out of nothing. And he would be an example of someone who is misusing science, representing the quantum vacuum or quantum fields to lay people as though they were nothing. And so saying that physics can explain how the universe can come into being out of nothing. And he was someone that I had in mind when I said that this is a deliberate misrepresentation of science to lay people, to present the quantum vacuum or quantum physical fields as though they were nothing. Sean Carroll is a very prominent cosmologist, and his answer is to propose a model of the universe which will be beginningless and eternal in the past. But in order to do this, his model features a reversal of time so that time runs in the opposite direction at a certain point in the past. So the universe would look sort of like an hourglass, like this, and above the neck, time runs in one direction, but below the neck, time runs in the other direction. The arrow of time flips over. And in this way, he says, you don't have a beginning of the universe. Now, wholly apart from the fact that this, I think, is completely non-physical, talking about a reversal of time's arrow, the more fundamental point is that it doesn't avoid the beginning of the universe after all. Because in no sense is this lower half of the hourglass in the past of the upper half. It's not earlier than it. It is in no sense the past. Rather, what you have here is really two universes with a common beginning point that are expanding in opposite directions. So that this model, far from avoiding the beginning of the universe, actually implies it, because this lower mirror image universe is in no sense in our past. So those would be examples of some responses to this consideration. Yes. Fascinating, isn't it? I mean,
I just wonder if you ever run up against students, physicists, cosmologists who come to faith in Christ, or at least a belief in theism through studying this stuff. It seems like all we ever hear about is the ones who argue against it.
Yeah.
Is it ever persuasive?
You know, it's difficult for me to know, because I will typically speak on a university campus in an evening event or a debate, and then I'm gone the next morning. And so I don't know. But I will say that at Reasonable Faith, we constantly get emails from students saying either that they have come to Christ, or that they have come back to Christ after having abandoned faith in God during their college years because of reading an article or watching a debate in which these arguments are presented. So in that sense, I can say yes, there are many, many heartwarming stories that we hear of people who have either come to Christ or come back to Christ through these arguments and evidence. And these are actually posted on our website under the section called Testimonials. And in our newsletter that I send out every month, we have a monthly report. We always append one of these testimonials to the end of the newsletter so that people can see its practical impact on real people's lives. Yes?
Obviously, all of this is way over my head. A friend of mine asked me to come sit in on this, but it's been my understanding that the gentleman came over and was looking at an hourglass on my notes. There was two particles floating around infinitely. They bumped into each other. That caused a reaction, which was the Big Bang. And I'm just talking generally.
Yeah, that's just pseudoscience.
Right.
I mean, that's just, that
So-
is not a serious physical model.
Right. My question is that, everyone, when it boils down to it, how is these particles or this Big Bang any different than God? Because you have two particles floating around, they come in contact, that causes the Big Bang, and which is the hourglass that you were speaking of. And isn't that hourglass happening in all things at all times to some degree?
Well, no, obviously not. I mean, this is the standard model, where, as I say, You should not think of the Big Bang as the result of two particles existing in some sort of prior space, floating around and coming into contact with each other. There is no prior space. There are no particles. This is the boundary of space and time, matter and energy. So what that person is talking about is just nonsense. Now here, if you want to have some particles in this mirror universe down here, they're not in our past. There is no causal connection between these and what goes on in the upper hourglass, because the arrow here, which represents time, goes from earlier to later, and therefore these particles are just irrelevant to the what's going on in the upper half of the hourglass. Yes, down here. You've been quiet today. No, can we get the mic down here, please? Oh, okay, we've got one over there first, sorry.
In the determine that there's a finite beginning of space and time, what kicks it off?
Now say it again.
So in that single point,
yes,
in time or space, what makes it start expanding? What's the input?
There's no explanation. I think that is a metaphysical question that a scientist cannot answer. Science leads you to the moment of creation, but there is no scientific explanation why this occurs. There cannot be, because there is no prior physical state for this. And that's why I say it fairly cries out for a transcendent creator of the universe. Yes, okay.
I wanted to comment on what he was saying about the possibility of there being a separate cause to the universe, like particles coming together, if I understand correctly. And the thing is that if you at any point can say that the universe is running down to a point where nothing will be able to happen again, then that event is sort of falls into the infinity fallacy, because if there's been an infinite amount of time before, and if you're saying that it's just particles or just a material event, then you could say that something happened before that. And so any event, like the running down of the universe, could have happened before. You can always say that an infinite amount of time could have passed before, and either way, we'd be at the dead zone right now.
We would be what?
We would be, so to speak, at the dead zone where everything is done with.
Yes.
Right now.
Yeah, that is kind of similar to the philosophical point that I made about the man counting down from infinity, counting all the negative numbers. Why didn't he finish yesterday or the day before that? At any point, it would seem he should have already finished. And it would be similar with regard to the thermodynamic properties of the universe, which is the second scientific confirmation, which I have to share with you, which concerns why is the universe in a state of disequilibrium if it has existed forever? If it has existed for infinite time, then it should not exist in the current state of disequilibrium. So we'll look at that next. Any other question then before we take our break? Yes?
With the expanding universe, there must be a border.
There must be what?
There must be a border around it. You go into nothingness, but how can something go in nothingness and exist?
Very good question. On the Big Bang Theory, the universe is not expanding into a higher dimensional space. There's nothing outside the balloon here. The balloon, the surface of the balloon is three-dimensional space, and there's nothing outside it. So what does it mean to say that it's expanding if it's not growing into something? The answer is that the internal distances between stationary objects increases over time, so that the mathematical properties of the space are the mathematical properties of an expanding space. The distances between objects grow over time. So the expansion can be measured and understood internally in terms of the increasing distance between stationary objects in space, like the galaxies. But the idea that this is embedded in a higher space into which it's growing is imaginary. You have to excise that from your imagination. Thinking of this higher space as just represents the poverty of our imagination. But in fact, mathematically, you don't need that higher dimensional space into which it's expanding. You calculate the expansion by its internal properties. All right, let's take a break at this point for 10 minutes.